This video is for the Ethereum Protocol Fellowship, and here we are going to talk about Oblivious transfer. So what is Oblivious transfer? It is a method based on the Diffie-Hellman key exchange that we use to allow Bob to be able to get some data from Alice without letting Alice know what data has actually been read. Now here Bob will pass a whole lot of keys to Alice, but only one of them will actually work. We have in this situation the employer Alice, the investigator Bob, and the suspect Eve, who might have committed a crime. Our motive is not to let Alice know that Eve is a suspect, as it could result in Alice firing her before she is even charged guilty. Let us take into account two employees, Eve and Trent, and here we already have Alice and Bob. So Alice generates a random number A. Before that, both Alice and Bob agree on G and P, which is a prime, out of which P is a prime and G is a generator. P is important because here all the operations are modulo P. So that's it. So Alice generates a random number A, uh, computes capital A is equal to G to the power A and sends it over to Bob. Bob also generates a random number small b. Bob asks Alice which index number, here in this case C, is associated with which employee. If C equal to 0, then Bob calculates capital B is equal to G to the power B. And if C equal to 1, Bob calculates capital B is equal to capital A G, into G to the power small b. So here we have consider that C equal to 0 is for Eve and C equal to 1 is for Trent. So the Bob sends the value of B over to Alice, and here since Eve is the suspect, the value of B sent over will be this. So Alice now takes B and computes K0 is equal to hash of B to the capital B small, to the power small a, and K1 is equal to hash of capital B by capital A whole to the power small a. So Bob then generates a key kr is equal to hash of capital A whole to the capital A to the power small b. Now if we notice that k0 and kr are equal in this case, as we are working with c equal to 0, they are both equal to g to the power ab. So two records M0, which is for Eve, and M1, which is for Trent, are encrypted by K0 and K1 respectively and sent over to Bob. Now notice that only one of these two encrypted records can be decrypted by the key Bob has, that is Kr. Here in this case it will be this one, as Kr is equal to K0. So Bob ends up decrypting only Eve's record and not Trent's. So Alice does not know which record Bob decrypted. And so this is how Oblivious transfer works. Thank you.